So we're in 6.10, we're wrapping up the chapter, and I'm honestly not sure why this is in chapter 6. This has nothing to do with anything we've been doing at all. I feel like this is a lesson we could have done the first day of school, we could have done it the last day of school, we could have done it any day in between, or we could have skipped it. The book throws it in at the end of chapter 6. I don't know where this does fit, because it really doesn't connect to anything we do all year. But I like sequences, so instead of skipping it, I'm just going to do it. If you like sequences, you'll be happy. If you don't like sequences, you're going to be mad. But this is almost like a replay of, well, 95% is a replay of 7th grade math. We did this lesson. We did all these sequences in 7th grade, and they're busting them back out. So if you like number patterns, you'll like this. If you don't, sorry, just survive the day. So a sequence is just an ordered list that follows a rule. Sometimes the rule is really easy, sometimes the rule is somewhat more complicated, but there's some sort of rule that I, as the author of these sequences, has a rule in my mind as I progress from one number to the next. And what they're going to ask you to do is predict probably like the next 2 or 3 numbers, something like that in the sequence. So let's do that, and then we'll talk about what the rule was. Sometimes there's more than one rule. Somebody could say, I'm seeing this, and someone else could say, I'm seeing that. And you're both going to be okay sometimes, but it just has to agree with the author and the numbers that we say. So some voice
10.
is 10, a different voice is 12, oh, the same voice. A new voice is 14, so those are all correct. So somebody with a hand, could you tell me what you're thinking there?
Just add 2.
Okay, he's thinking add 2. So that is going to continue to be true. If you're thinking add 2, that's a fine way for your brain to think. You're going to agree with the author. Somebody else have a different way to look at those? These have a name. Evens, just go through your even numbers. So if you're thinking of the next even number, your brain is thinking a different way, but you're going to land on all the same stuff. Somebody, if you wanted to make this a little bit trickier, could think times tables. 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6, 2 times 7, so 2 times 8 is next. If your brain is thinking that way, you're fine. We're all in agreement. Those are all just different descriptions of that same list. 3 different rules, kind of, but same list in the end. Question about that one? So any voice?
9.
Agreed. Different voice?
11.
A different voice?
14.
13. We could do that all day. Sometimes you'll see something like that, meaning it could go on forever. But what are we thinking that time? Somebody with a thought. What's the rule?
Odds.
Odds, if you like thinking that way. Or we could think about each time we're adding 2. Or if you wanted to get really like complicated, it's 2 times 1 minus 1. 2 times 2 minus 1. 2 times 3 minus 1. 2 times 4 minus 1. 2 times 5. 2 times 6 and 2 times 7 minus 1. How many people would think that way? Probably not many. But those are all fine rules that we could explain that list that would generate those numbers. Question there? So next up,
You're adding 5.
adding 5. Gave away the rule too soon. I like the numbers then the rules. The spoiler, you just have to say spoiler alert when you go busting that stuff out. So yeah, we are adding 5.
21.
21 will work.
26.
26 will work.
31.
31 will work. Something like that's called an arithmetic sequence. You don't need to know that name. Someday we bring this stuff back out at the end of Algebra 2 or sometime during trig if you stick around math that long. There's a lesson about sequences. One day it's any of them, another day it's just arithmetic sequences, and we do some stuff with that. But yeah, adding 5 works. This would also work as 5 times stuff minus 4. 5 times 7 minus 4, 5 times 6 minus 4, 5 times 5 minus 4, 5 times 4 minus 4, or if you go 5 times whatever minus 4, it builds that way. Question about that one? This one's going to get big.
768.
It is 768. And then if you go next, people are either going to need pencil paper, or wish I'd let you use the calculator for a second, or be really pretty good at mental math. Ugh.
Is it 3 3,072.
It is 3,072. If we want to go again, let's go. What's the rule? Give it away earlier this time.
Multiplying by 4.
Multiply by 4. There would be another way you could explain this with exponents, but that gets even probably less familiar in your memory banks be doing powers of 4. But yeah, it's going times 4 every time.
$12,288.
That is a win. That's called a geometric sequence someday in trig. They come back around. It's multiplying 4 every day. Excuse me while I got. The next one's the first one. Sometimes I say no.
25.
People try to say some numbers and sometimes I say no. 25 is next.
36.
You got it, so you can't get greedy.
Oh, 36.
It is 36. Different voice. Who's that?
Wow.
Ran out of steam. Anybody willing to give a shot? Who's next? You can go again because I don't know if you actually
No, I
knew or
can
you
go.
just stole
I
our
just
answer.
stole
So
it.
yeah, you're okay if you want to go again. I'll let you give the rule, but we'll see if anybody else can figure out another one or ideally 2, because both of those would come out. Anybody willing to shoot? Worst can happen is I'll say no. I'm sure you've heard that word before. There's 2 ways that you can look at this. One involves times tables. One involves addition.
Is the next one 49?
The next one is 49. Different voice willing to shoot a third time.
66.
It's in the 60s. Not far off.
64.
Yes. What were you thinking, rule-wise?
You just add the next odd number.
Okay. If you're thinking adding, we're adding odds. Add 3, 5, 7, 9, 11, 13, 15. That's true. Anybody have a times table explanation?
Times it by 5 minus 1.
No, it won't work quite like that all the way through.
So you would for the 4, you'd do 2 times 2, 4, 3 times 3, 9, 4 times 4, 16.
It's your times table doubles, or however your teachers in elementary school called them. 2 times itself, 3 times itself, 4 times itself, 5 times itself, 6 times itself, 7 times itself, 8 times itself, and so on. Those are called perfect squares. It's a name for that list as well. Or if you're good at square roots, it's like the numbers you can do square roots of. Like the square root of 64 is 8 because 8 times 8 turns into 64. Through all those. Here's the trickiest one of all. Just one number out of you and no patterns.
Okay.
All right.
5.
5 is next.
You said only one number?
Yeah, just one from you for now. If we strike out hard, I'll go back to you.
7.
Not a 7. This is another one. I usually say no a few times.
It's a 9.
It is not 9. Well, at least we're shooting. And we'll run out of numbers and hit something eventually. And then sometimes when you get a new number, people go, oh, I see where that came from.
10.
5.
No.
Carter, you got anything?
There's only one number we didn't say in that range, and it's the one we want.
7.
8 we didn't say yet. So it is 8. There's some sort of reason why 8 just emerged.
Is it 13?
13 is next, so you probably just figured it out. There's some reason why 13 just happen based on what is going on here. Everybody predict who's next. Who didn't get one right there. You saw this in 7th grade, if you had me for 7th grade. It has an Italian name. Back to you.
21.
21 is next. There's some sort of reason why 21 just popped out. And if we can figure out why, we could get 34 is next, and then we'll ban YouTube. And then there's something's gonna pop out next.
Wow.
68,
No, it's gonna be in the 50s.
54.
No. Did you have a strategy, or you were just guessing?
I just
stuff?
guessed.
I'll say this, it has to do with adding. It's definitely an adding only moment. Go back to you.
55.
55 is next, so there's some reason why 55, like, is the number that just popped out.
80.
Well, yeah, well, I'm gonna put you on hold. We're gonna get up to the 80s, but not give it away, because you got it. I was hoping for one more breakthrough, because I'm greedy like that. How are you doing that?
I just add the last one before it.
Add who?
Like, so if we're doing 55, I just add 34.
Yeah, what we're gonna go do next is take 55 plus 34 and turn out 89. You add the final two that are shown. If we go all the way back to the beginning, those add up to make 2. The final two make 3. 2 and 3 make 5, and on down the list. Where we are on homework here, we're 262, working 1 to 5, 7, 10, and 14. This is called the Fibonacci sequence. So what they're going to ask you to do is build your own. They'll give you like 2 starter numbers. So let me say I give, pick any number under 10, somebody.
7.
7 and,
6,
let's go out,
8.
8. So if we start with 7 and 8 and play the same style game, who would come next? 15,
And then 23.
23,
38.
38, and you can build. Some of the homework, they just want you to build your own. But it's 1 to 5, 7, 10, 14, 262, that's it.